Hey programmers, Alvin here. Right now I want to go over a approach for this linked list values problem. So we'll hop right in right here. In this problem, you're going to be given the head node of a linked list. What we want to do is return an array containing all of the values within the nodes of that linked list. And we should do it in order. Bear in mind in this problem, we're given a singly linked list, which means that every node has a pointer to the next node in the linked list. We know that the last node of the linked list would have a next pointer that points to null. But that being said, how can we go about solving this one? Well, this problem is we're just going to have to force you to implement a really core linked list pattern. That is, just traversing through a linked list in order. And so we'll start by attacking this one maybe with an iterative description. So let's say we started from ground zero, right? So we want to create our values array. And to the side, we can just initialize values to be an empty collection. And to implement this core pattern of just traversing through a linked list, we're going to need a variable or just a pointer. And we're going to start at the head of the linked list, right? Bear in mind that our function only takes in the head, but I know the head is like the ultimate starting point of the linked list, and eventually I could access everything throughout the entire list. So I'm going to set my current equal to the head, and what I can do off the bat is just check current's value and add it to my running collection. So I have the a value inside of values now. And since I have access to the current node, I know that if I access its next property, I would have access to the next node of B. So what I can do is set current equal to current.next, basically just moving my pointer to the next node like this. Same thing as before, I can add my current value into the collection. And I'll just proceed in this way, right? Same thing for C, set current equal to current next. And things get interesting once we approach the tail of this linked list. So I'm currently at the D node, and I go ahead and add that value into my values list. What we'll have to do now is consider the scenario when it's appropriate to actually stop our traversal. Well, bear in mind that D's next actually points to null. So maybe I'll draw that explicitly just for this drawing. So D's next is just pointing to null, which means if I continued this algorithm in the general sense, so I set current equal to current next, that means my current pointer now points to null. And I think that would be a perfect stopping condition, right? So once current is null, we know that we've hit the end of our linked list, and so we're totally done. And if you look at the order of our values, it is indeed the correct order, right? What can we say about the complexity of this algorithm? Well, if we say that n is just the number of nodes in this linked list, then the time complexity is going to be O of n, right? Because we're just really iterating through every node once. And our space complexity, if we consider the output array, it would just be also linear in the number of nodes over here. And so I'll tell you what, this looks like a pretty good strategy that we can go ahead and implement. We'll implement it in two ways. First, I'll show you the iterative version and also show you how to implement this one recursively. Really, both the iterative and the recursive code use the same sort of mechanisms. So I'll see you in the walkthrough video.